Hey guys, it's Mr. C, and in this video, we're going to be looking at some multi-step equations. And when we look at these multi-step equations, I never assume that students know everything right at the beginning. So what we're going to do is we're going to kind of run through the gears here. We're going to start off slow, and then we're going to work ourselves up to the more difficult ones. And so first thing we're going to take a look at is we'll take a look at some one-step equations, and then we'll move into two-step, and then we will start looking at some multi-step. So let's take a look at, first of all, this little equation here. X plus 7 is equal to 12. So as you saw in my previous videos, you have a river there. You need to subtract 7, opposite operation. Cancel those out, additive inverses. Bring down your X. And 12 take away 7 should be 5. And so 5 is the solution. One step. Okay, so for this one, again, a one-step equation. We're going to go ahead and draw a river there. And so you have x minus 3, so we need to get rid of that minus 3 with a plus 3. Isolate the variable, which means get it by itself. Additive inverses. Bring down my x. And negative 14 plus 3 should be negative 11. And that one is done. 4 minus x is equal to 10. Let's take a look at this one. We need to get rid of that 4. And so here's our river. So we need to subtract 4 on both sides. We always deal with the constant first. And there's only one constant over here. So minus 4, cancel. This time I got to bring down this minus x. So the whole minus x comes down, can't forget that, equals 10 take away 4 is 6. Now there is one more step you have to do for this one. This time, you have a minus in front. You need that to be a plus. And so what we need to do is just divide both sides by negative 1. When you do that, that minus cancels, and you get x is equal to 6 divided by negative 1 is negative 6. So just be careful of that. When there's a minus in front of the x, you're going to have to do one more step at the end to get rid of it. Here we have 3 minus x is equal to negative 5. So again, we got to subtract 3, subtract 3. Additive inverses cancel. I'm going to bring down my negative x. Remember, I always say negatives and minus are the same thing, because they really are. Negative 5 take away 3 should be a negative 8. And now to get rid of that negative there, I have to divide by negative 1. You could multiply by negative 1, but I always divide. Cancel, and x is equal to 2 negatives on top of each other, make a plus. So that is going to be a positive 8. All right, so now we have this one. This one has some division in it. So how are we going to handle that division? Well, this time we're going to, we need to get rid of that 4. So how do we get rid of the 4? I'm going to multiply both sides by 4 because it's being divided. So I'm going to do the opposite operation. These two 4s are actually multiplicative inverses. They cancel out. And whatever's up here just drops down, equals whatever this turns out to be. 4 times negative 2 is negative 8. And so that way, for that one, that's our solution. Negative 8. All right, we have another one, kind of looks the same. Okay, this one, I'm going to multiply both sides by 3 to get rid of that 3 right there. So there's my river, 3 and 3. Multiplicative inverses, cancel. Whatever's up here drops down. 5 times 3 is 15. And that is all we can do for that one. So just remember, when it's division, you have to multiply. When it's multiplication, you have to divide. Do the opposite operation. Okay, this time we have a 6 down below, so we need to get rid of that 6 by multiplying both sides by 6. Okay, so now those two 6's cancel. Drop my x down. And 6 times negative 3 is negative 18. And that's it for that one. And our last one-step equation here, you got the x sitting here. So I don't know if you remember from our previous videos where I showed you this, but you can take these two guys right here, as long as it's a fraction equal to a single number, you can take these two guys and swap them out. That one you can't. You have to leave that one alone, the numerator. You can take these two guys and swap them out. And so I can actually write 8 over negative 4 equals x, no problem. 8 divided by negative 4 is negative 2. And so now, easily, I can get the answer of negative 2. Or you can write it as x equals negative 2. I don't really mind which way you write it. Most people are going to write it like this, but it doesn't matter because it's what x equals, and since that's an equal sign, you're free to switch them however you want. No problem. Okay, so let's move on to some two-step. Two-step again, remember that you have to take care of the constant before you take care of the coefficient. So you're going to add 5, additive inverses cancel. We're going to drop down our 3x equals 5 plus 4 is 9. Next step, we're going to divide by 3. Multiplicative inverses cancel, and x is equal to 9 divided by 3 is 3. Just to review, another two-step. Okay, this one, subtract 7. We're going to bring down our 2x equals 11 take away 7 is 4. And now our last step, divide by 2, cancel, and x is equal to 2 for that one. This one is interesting because you have a minus in front of the 5 there, but that's okay. We need to take care of that constant first. That's the constant, that's the coefficient. Constant always comes first. So minus 4, cancel. We're going to bring down that minus 5x, negative 5x equals 19 take away 4 is 15. And then our final step, we're going to divide by negative 5, the whole thing, the whole coefficient. Cancel, and x is equal to, positive over negative is still negative, negative 3 for that. And finally, our last one here, well, not our last one, but this one. River, we're going to subtract 3, get rid of that constant first. Bring down our 4x. Negative 25 take away 3 is actually going to be negative 28. Got to be very careful and accurate with these negative numbers when you're combining them. Divide by 4, cancel, and negative 28 divided by 4 turns out to be negative 7. So just be really accurate and careful when you have negative numbers when you're combining them. Okay, so we got, I guess, a couple more two steps. Okay, this one, subtract 3, cancel. It's just routine now, right? Bring down your 7x is equal to 17 take away 3 is 14, and then divide by 7. Cancel those guys out, and x is equal to 2. Let's change colors from green. I'm kind of bored with that. All right, so here we have another one. Okay, so this time the x is on this side. I still need to get rid of the constant with it. So there's my river, minus 6. I'll do it like that. Cancel, 12 take away 6 is 6, equals negative 3x. Don't let it fool you or confuse you when it's switched. Divide by negative 3. Some students are so used to the left-hand side that when you give them something on the right-hand side, they have a really hard time with it. But it's the same thing. Cancel those guys out. 6 divided by negative 3 is negative 2. And so your x solution is negative 2 for that one. All right, this time I'm going to employ the method of clearing out fractions. So I'm going to multiply everything up there by 2. So 2 times 1/2 x minus 2 times 1 equals 2 times negative 5. I do this whenever I can because it makes my life a lot easier. These two cancel, multiplicative inverses, bring down my x, minus 2 times 1 is 2, equals 2 times negative 5 is negative 10. Now I'm going to add 2 to both sides. Bring down my x And negative 10 plus 2 is negative 8, and that should be my solution for that one. So much easier when you clear fractions out. It's up to you though. If you want to deal with fractions, multiplying and adding and subtracting, you can go for it. But I try to avoid them when I can. All right, and this is going to be our last two-step. Let's see, river, subtract 11, always the constant first, then the coefficient. Negative 4x equals negative 5 take away 11 is negative 16. Divide by negative 4. Cancel those guys. And x is equal to negative over negative is positive, positive 4. All right, that's the two steps. Now let's get into some multi-steps. Multi-step equations with variables on one side only. Next time they'll be on both sides. But this time they're on one side. So you have 2x plus 3x minus 7 is equal to 23. And so what you have to do first on these is you have to clean them up before you can do the two-step equation. So what happens usually is if the variables are on one side only and there's a constant on the other, you have to clean up one side and then it's going to drop down to a two-step. So for instance, 2x and 3x, that makes 5x. Still minus 7 equals 23. So see, it actually made a two-step equation. So now you just solve it just like we did all the other ones. Add 7, drop down your 5x, 23 and 7 make 30, divide by 5. And some of this you can do in your head. And so x is equal to 6. Not a problem. Okay, this one, multi-step. On the left-hand side now you have 7x and a negative x. Well, the 7x and the negative x are going to combine to make 6x. Still plus 8 equals 35. So now we're down to a two-step equation. Subtract 8, subtract 8. Bring down your 6x equals, so 35 take away 8 is 27. And now you just have to divide by 6. And x is equal to, for the moment, 27 divided by 6. All right, so 27 and 6, do they have anything in common? Yes, they're both divisible by 3. So we're going to divide them both by 3. 27 divided by 3 is 9. And 6 divided by 3 is 2. So for that one, you should get 9 halves for your final answer, and you always want to simplify it if you can. All right, so let's take a look at a few more here. Okay, now we have some problems that have a number in the denominator. So let's see how we're going to handle this one. What I would do is I need to get rid of that 4 first. That's really hurting me. I can't really subtract 17. I can't deal with that negative until I get rid of that 4 right there. So I'm going to multiply both sides by 4 to get rid of it. When I do that, these become multiplicative inverses. They cancel. 17 take away x drops down, and it's equal to negative 40. Now I need to get rid of that 17. So I'm going to subtract 17, drop down my negative x, equals negative 40 take away 17 is a bigger negative, and it's negative 57. Now, they both have negatives on both sides. So I need to divide by negative 1, cancel those out, and x is equal to positive 57 for that one. All right, so let's take a look now at this one. So now we have one, and it's a lot like the last one, but we need to get rid of that negative 6 first. So when I ask students, what do we get rid of first? The negative 3, the 4, or the negative 6? Many students always say the negative 3, but you can't get rid of that until you get rid of this down here. It's got to go. So we're going to multiply both sides by negative 6. Now these are going to cancel. Now I drop down this whole thing. All of this is going to drop down below negative 3x plus 4. So think of it like it got unlocked. 12 times negative 6 is negative 72. Now, that's still a two-step equation. So subtract 4, subtract 4. Bring down your negative 3x equals negative 72 minus 4 would be negative 76, right? Okay, negative 76. Divide by negative 3. Those cancel. And now x is equal to positive 76 over 3. Can you simplify that? 76 and 3 have nothing in common. 6 plus 7 is what? 13? And 13 is not a multiple of 3. So therefore, that fraction, you just leave like that. Don't turn it into a mixed number. Just leave it as an improper fraction, and we're fine with that. All right, so now let's see how we're going to handle this one. Find 3 consecutive odd integers whose sum is 51. Okay, so 3 consecutive odd integers. Let's see how this one's going to work. Integers that are consecutive go 1, 2, 3, 4, and so on. Those are consecutive integers. Well, we don't know what the first one is. And so we're going to let the first consecutive odd integer be x. Now, whatever that is, the next odd number, you have to add 2 to it, right? Because if it's consecutive odd integers, it's going to go 1, 3, 5, 7, and you're always adding 2 to the next one. So if x is the first one, the next one would be plus x plus 2. Now the next one after that, you'd have to add another 2 to it. So it's not x plus 2, it'd be x plus 4. There's 3 consecutive odd integers. I have no idea what the first one or second one or third one is, but I do know that it's going to follow this pattern. Now it's got to be equal to 51 somehow. So let's take a look at this left-hand side and let's see if we can clean it up. We got a plus parentheses, plus parentheses. So as we've seen before, when that happens, you can just get rid of these parentheses. X plus 2 plus x plus 4 equals 51. All right, how many x's do we have over here? 1, 2, 3. So 3x plus 2 plus 4 is actually a plus 6 if you combine them, equals 51. Now we have a two-step equation. Subtract 6, subtract 6. Cancels, bring down my 3x, equals 51 take away 6 is 45. Divide by 3, and x is going to be equal to 45 divided by 3 is 15. So what I've just found now is the first consecutive odd integer. So if 15 is the first one, and it says to find the 3, I need all 3. So 15 is the first one. Let me write them in a different color. So 15 is the first one. The next one would be 17, and the next one would be 19. So if you add those 3 numbers together, you should get 51. 15 plus 19 plus 17 should be 51. The thing is some students want to run through a bunch of numbers until they happen upon the 3 numbers that equal 51 or whatever it is, and then think that they did something. Well, what they're going to do to you later is they'll make that number really big. And then they might have 4 or 5 consecutive odd integers. So if they make this number really big, it's going to be really hard for that person to sit there and run through all those combinations. So if you write it as an equation, then you solve the equation, it's really not that hard, you will get the first one, no problem, all right? So I always suggest that you do all this work because your teachers are going to want to see it anyway. And if you just did it by inspection, which just means found it by looking, they're probably not going to give you credit for it, even if it's right. Find 3 consecutive even integers whose sum is negative 30. Well, even integers are basically follow the same pattern as odd integers. So if we let x be the first one, then x plus 2 would be the second one, and then x plus 3 would be the third one. Oh, no, not x plus 3, I'm sorry, x plus 4 would be the third one, equals negative 30. Now we're going to force x to be the number that has to be true to make these 3 consecutive even integers negative 30. It's going to happen. So we're going to do the same thing we did before. We're going to remove parentheses. It's pretty cool because we're actually going to get the same exact left-hand side. Okay, again, 1, 2, 3 x's. Positive 2 and positive 4 make 6 equals negative 30. Now I could do something real cool here to make my life easy. I could divide all 3 of these by 3 to make my equation a one-step. But I'm not going to do that right now. I'm going to go ahead and just do it like I always do. Minus 6, cancel, bring down my 3x is equal to negative 36, divide by 3, and x is equal to negative 36 divided by 3 is negative 12. So negative 12 is the first one. So what's the second and third one? Negative 12. Now if I'm adding 2 to that, that would be negative 10, wouldn't it? And if I add 2 more to that, that would be negative 8. Because I got to remember, I'm adding 2 each time. I'm not adding a negative 2 each time. If I go backwards, negative 14 and negative 16, it's probably not going to work. So if we check our answer, if we add all those up, negative 12, and I'll just change the sign. I'm not worried about the sign. 10 and 8. If I add all those together, they're all negative anyway. 8 plus 2. Carry the 1, 1, 2, 3, regroup, I guess they call it now, 1, 2, 3, 3, and I get 30. So now I've checked my work, they all add up to 30, and I'm good. So negative 10, 12, negative 10, and negative 8. This one is going to be fun. Find 4 consecutive integers whose sum is 94. Just integers. Okay, so 4 consecutive, not even, not odd, just integers. So if x is the first one, the very next one would be x plus 1. The next one after that would be x plus 2, because I'm just counting by ones now. The next one after that is x plus 3. This represents 4 consecutive integers. Let's see, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. So all of these are going to be consecutive integers. Equals 94. Okay, so plus, 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 we can remove the parentheses. Plus x plus 2, plus x plus 3, equals 94. So where do you see these kinds of problems? Those are going to be in the textbook, where they're the hardest ones, the challenge problems, the hot problems they call them, or those are EOC questions, because they love these on EOCs. All right, so how many x's do we have? 1, 2, 3, 4. So we have 4x, constant, 1, 2, and 3. So 1 and 2 make 3, and 3 and 3 make 6, right? Let me make sure. 1, 2, 3, 4, 5, 6. So plus 6 is equal to 94. So we're going to subtract 6, cancel, bring down my 4x is equal to 94, take away 6 would be 88. All right, we're going to divide by 4. X is equal to, so what is 88 divided by 4? That should be 22, right? Okay, so let's see what our numbers are. Our first one's 22. Our next one is 23. Our next one's 24. Next one's 25. Okay, so let's check our work over here and see if that's right. 22, 23, 24, 25. All of those have to add up to 94. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Regroup. 2, 4, 6, 8. Another one makes 9. And it does indeed make 94 when you add them all together. So those are some multi-step equations with variables on one side. And next time we're going to tackle equations that have variables on both sides. So remember to like my video and subscribe to my channel, and we'll see you guys later. Bye.